Good morning, viewers. David De Los Reyes, February 17, 2022. We are here in Los Angeles. My topic for this afternoon is integration by trigonometric substitution. Okay, guys, let's proceed for us to study integration by trigonometric substitutions. This is lesson number 33 under my integral calculus, which is under my channel. So we've got lots already of topics under integral calculus. This is now lesson number 33. That's only for integral calculus. We are done with differential calculus, so you just follow my discussion on differential calculus. That was ahead of this. Okay, let's proceed with the discussion for this afternoon. Integration by using trigonometric substitution. Trigonometric substitution meaning it should be as a function of sine theta, cosine theta, tangent theta, secant theta, plus the other two. That's trigonometric. Okay, there are 6 variations for the trigonometric substitution. Okay, variation number 1. If the given integrand got a term a square minus x square, the trigonometric substitution should be x equal to a sine of theta. Where a could take any constant value. Okay. If the given integrand is of the form a square minus x, only minus x, we let x equal to a square sine square of theta. Okay. Second variation. If the given integrand is contains a square plus x square, it's plus. The required trigonometric substitution should be x equal to a tangent of theta. Okay. If the given integrand contains a square plus x, only x, the required trigonometric substitution should be x equal to a square tangent square of theta. Variation number 3. If the given integrand contains x square minus a square, it is the reverse of this. Okay? X was ahead. Okay? X square minus a square, the required trigonometric substitution should be x equal to a secant of theta. Okay? If the given integrand contains only x for the first term, it's not, we are done with the x square, only x minus a square. The required trigonometric substitution should be x equal to a square secant square of theta. What's the significance of this one, guys? In this one here, we are to use sine square of theta plus cosine square of theta equal to 1. We need this identity upon the substitution of this. For this one here, 1 plus tangent square of theta equal to secant square of theta. Okay? The third one, 1 plus cotangent square of theta equal to, oh, sorry for this one. For variation number 2 and 3, we use this identity. Okay? So memorize these 6 variations or 3 variations by heart and plus this substitution here. First one, x equal to a sine of theta Second one, x will be a square sine square of theta. Third one, x equal to a tangent of theta. Fourth one should be a square tangent square of theta. Fifth one, it should be a secant of theta. The last one should be a square secant square of theta. And to simplify the solution for this last four here, we use this identity. For the first one, we use this identity. Okay, let's proceed with first example. The given example is the integral of dx over the square root of a square minus x square. Okay? Disregard for the meantime the radical sign. Just take note of the one inside. Okay? The one inside is of the form a square minus x square. Out of the 6 equations, formulas, it falls under this, right? Right? So we will let x equal to a sine of theta. Luckily, the constant inside is a. So we will let x equal to a sine of theta. This is actually our trigonometric substitution, TS. Okay? Taking the differential of both sides. The differential of x is dx. The differential of a sine of theta, constant, a function, it should be constant times the differential of the derivative or the differential of that function. So it should be a. The differential of sine is plus cosine, okay, times differential theta. Or dx is just simply a cosine of theta differential theta. Going back to the problem now, rewriting. Now, let's compute for the value of the square root of a square minus x square as a function of the trigonometric substitution. Equal to the square root of, we are following this, a square minus x square. But what is x? What is x? X is actually a sine of theta. So this should be a sine of theta quantity square. So what will come out will be a square minus a square sine square of theta. We factor out a square times the quantity 1 minus sine square of theta. Then try to replace this value here, 1 minus sine square of theta, because we know that sine square of theta plus cosine square of theta equal to 1, right? Therefore, 1 minus sine square of theta, okay? We place this on the left, alright? And this should be equal to cosine square of theta. So meaning 1 minus sine square of theta is equal to cosine square of theta. It's this. It comes from this. Right? So what will come out will be the square root of a square. The equivalent of this in terms of cosine is cosine square of theta. Then take the square root of both sides. The operation inside is multiplication. And they are both perfect square. Right? So the square root of a square is plus or minus a. We will take the a plus a. The square root of cosine square of theta is just plus or minus cosine of theta. We will just take the plus. So the equivalent of this is just simply a cosine of theta. Okay? Therefore, the integral of dx over the square root of a square minus x square is equal to the integral. What is dx? Dx is actually a cosine of theta differential theta. And the equivalent of this in terms of the trigonometric substitution is a cosine of theta. And luckily this term here cancels with this. The operation of the numerator is multiplication all over one common denominator, and luckily this one here is same as this, so it cancels out. So what will remain on the right hand side will just be simply the integral of differential theta. Okay? And this will cancel out. Right? So the right hand side will be theta plus c. But what is theta? What is theta? From our trigonometric substitution, x is equal to a sine of theta. So if we divide both sides by a, okay, right hand side, this cancels. Sine of theta, we place it on the left, therefore sine of theta will be x over a. Okay? To remove this sign here, take the arc sine of both sides. Arc sine. Okay? The arc sine of the sine of theta is just theta. And the arc sine of x over a is just the arc sine over a. When this arc sine goes near this sine, they will cancel out. Okay? Right? Left hand side will just be simply theta, and the right hand side will be arc sine of x over a. So the final answer is actually theta plus c, but theta in terms of x is actually arc sine of x over a plus c. That is the final answer in terms of x. Okay? It's easy, guys. Trigonometric substitution. Okay, let's proceed with example number 2. A little bit complicated, guys. Eye contact. Okay. Example number 2, the integral of x plus 3 quantity dx all over the square root of 16 minus x squared. Disregarding for the meantime the radical sign, the one inside is actually 4 square minus x quantity square. And it falls under still formula number 1. Okay? So, this is A. Okay? So, we will let x equal to 4 sine of theta. Where did this 4 came from? It came from here. Right? This is our trigonometric substitution. Right? X equal to 4 sine of theta. Find for dx. Differential of x is dx. The differential of the right hand side constant in the sine function. So it should be 4 times the differential of sine of theta. It will be cosine of theta, differential theta. So dx is just equal to 4 cosine of theta, differential theta. Let's try to compute for the value of the square root of 16 minus x squared as a function of the trigonometric substitution. This should be equal to the square root 16. We are following this. X is actually 4 sine of theta quantity square. Okay? Is it correct? Then this will be 16. Okay, I will try to erase this. I will show you. There's no magic, guys. I want to show you that I could write on the board while I am teaching, you know. This is a spoon feed, but it's more understandable to the students. Okay, I will try to simplify this one. This should be equal to 16, okay, minus 16 sine square of theta equal to square root of, we factor out 16, then this is 1 minus sine square of theta equal to the square root of 16. 1 minus sine square is cosine square of theta. Perfect square, we take the square root of 16. The operation inside is multiplication, right? So the square root of 16 is 4, plus or minus 4, or we will take the positive sign. The square root of cosine square of theta is cosine of theta. So this will be 4 cosine of theta. It is this. Okay? Going back to the original integral, therefore, the integral of x plus 3 dx all over the square root of 16 minus x equal to the integral. What is x? X is actually 4 sine of theta plus 3. We are following this. Plus 3 times dx. What is dx? It is 4 cosine of theta differential theta all over the equivalent of this, in which we solve separately. And that is actually 4 cosine of theta. It is this. Right? The resulting denominator, okay, is 4 cosine of theta. The operation on the numerator is multiplication. This is 4 cosine of theta differential theta. This is 4 cosine of theta. So 4 cosine of theta cancels. Okay? So what will remain on the right hand side? It will be 2 terms. The integral of 4 sine of theta differential theta, it is this. Second term is 3, okay, times the integral of differential theta. 4 the integral of sine theta differential theta plus 3 the integral of differential theta. It is now integrable, right? So this should be 4. The integral of sine theta differential theta is negative cosine of theta plus the integral of differential of theta. This will cancel out. So it will just be simply 3 theta plus c. Okay? Continuation. This should be negative 4 cosine of theta plus 3 theta plus c. This is the answer in terms of the trigonometric substitution. Let's try to bring out the answer in terms of x. From the given equation, x equal to 4 sine of theta. X equal to 4 sine of theta, right? Divide both sides of the equation by 4. This cancels. Sine of theta will be x over 4. Actually, we could construct a right triangle with this definition of sine of theta. Sine is opposite over hypotenuse. Sine of theta is x over 4. Opposite this hypotenuse, so this should be x, this is 4. The adjacent side, considering this angle, is the square of this minus the square of this, then take the square root. Okay? Therefore, we need the value of cosine of theta. The cosine of this angle here is adjacent over hypotenuse. Cosine of theta is the square root of 16 minus x squared over 4. To bring back the final answer in terms of x, this should now be equal to, we are following this. This is negative 4, right? Times the value of cosine of theta, but cosine of theta is 16 minus x squared the square root over 4, it is. Plus theta. Theta is actually, have I bring out the value of theta? Oh, not yet. Oh, there is a solution for this one. For the value of theta, we derive from here. Okay, x over a equal to a sine of theta over theta. Theta is actually x over a. Theta equal to arc sine of x over a. Okay, so the final answer, this should be negative 4, this cosine of theta, plus theta. Theta is arc sine of x over 4, plus c. And this 4 here, cancel with this. So the final answer in terms of x, this should be negative the square root of 16 minus x squared. This is preceded by negative sign. Plus arc sine of x over 4 plus c. That's it, guys. It's easy. As long as you know your trigonometry, okay, trigonometric identities, it's easy to solve problem under integrals involving integration by trigonometric substitution. That's it, guys. We have 2 examples. Okay, I given you the 6 variations. Actually, the 2 examples for today is actually regarding variation number 1. That is x equal to a sine of theta as trigonometric substitution. That's it, guys, for today. Next lesson, it will be a trigonometric substitution, maybe using variation number 2 and number 3. Good afternoon, Los Angeles.